Okay, hello and good morning. Let's take a look now. This one right here is substitution. This was number 10 on your worksheet. So to work this one, you see how y is by itself? So you could use either one of these. I'm just going to take this first one and plug it in place of that y. See how it says y? You're going to substitute right here. So you could scratch that out and put negative 3x plus 4 is equal to 4x minus 10. Now, when you substitute, you should have all x's or all y's. But if you have an x and a y, then you put it in the wrong spot. Now, a lot of you were taught differently. You can't add or subtract these because they're on opposite sides of that line right there. But what you can do is go after the smaller one, and that's the way I teach it. You see 4x is bigger. It's a plus. And a positive is always bigger than a negative. So I would add 3x. It's not the only way to do it. It's just the way that I teach it. And then that way it becomes a positive. You see, you have a positive 7x as opposed to a negative 7x. So I get 4 is equal to 7x minus 10. And now you have a two-step equation, which you should be able to do. So you're going to add 10 to both sides, and that gives you 14 is equal to 7x. You divide by 7, and that gives you x equals 2. So put a 2 for the x position. For the y, you can plug it in here or there. I always go back to my circle. So scratch the x out and put a 2. Negative 3 times 2 is a negative 6 plus 4. You have more negatives, so that's a negative 2, and that should be your answer. Now, if you really want, you could plug in the x here and the y there and see if they equal. But it's got to work for both of them, okay? And what happens is that's where the two lines cross, and that's called the solution. Today we're going to learn elimination. This is the third method. Copy down this problem right here. All right, to do elimination, you got to line up your x's, line up your y's, and then line up your numbers. Just like that. X's, y's, and numbers. Okay, well this one's already done for us. Now look, you try to make something eliminate. Well, you could do the 8 and the 3, but you'd have to use 24, and that's a lot of work. This one right here, if one of these was a negative, these would cancel out. So you're going to change this to a negative, but you just can't change one of them, so you got to change all of these. So put a negative right there, and then put that wave. And that wave means you got to change. So it's going to be negative 8x minus y equals a positive 16. The bottom stays the same. Now look what happens. Look what we did. Now we made these two eliminate. So cancel them out. So that gives you a negative 11x is equal to whatever that is. A positive 11. Divide by negative 11. And you get x equals negative 1. Now you might be saying, well, why do we want to eliminate? Can't we use substitution? Absolutely you can. Can you graph it? Absolutely you can. But elimination is one of those third processes where sometimes it's better. Not all the time, but sometimes. Now you get to pick whichever equation you like. Which one looks friendly to you? I like the bottom one. So I'm going to say 3x plus y equals negative 5. I'm going to substitute a negative 1 right here for my x. Double negative makes a positive. Say that to yourself. Two negatives make a positive. So I get this, and then I subtract 3, and I get a negative 8. And that should work. And there it is, and that's called elimination. Do they get harder? Yeah, they do. Like, take a look at this one. Copy this down. This one right here, nothing cancels. Okay, and there's no easy fix. I can't just multiply by a negative. But what I can do is decide which one I want. Okay, doesn't matter because both of these are going to be work. But I'm going to go after the x's. So you take the 3 times the 5, and you get 15. So I'm going to make all of these front ones 15. So I'm going to multiply this top one by a 5. That gives me 15. I'm going to multiply this bottom one by a 3. Now watch what happens, because I think we got to do a little more work to it. So 5 times 3, that gives me 15x minus 10y equals 10. 5 times 2 and 5 times 2. 3 times 5 gives me 15x minus 15y equals 30. But look here. These are the same, but they're not going to cancel. See, one of them has to be a negative. So we probably should have multiplied by a negative 5. So we want to go ahead and put a negative here and change these signs like we did in the one above. Okay? So I get a negative 15x plus 10y equals negative 10. And then the bottom stays the same. So I get 15x minus 15y equals 30. Now this cancels, you see? So this gives me a negative 5y is equal to whatever that is, a positive 20. I divide by negative 5 and I get y equals negative 4. So y is negative 4. You can see this one was a lot of work, and some of them will be. Now you get to pick whichever equation you like. You could use this one, but these are ones that I modified. I would go back to the original. So pick one of the original ones. I'm going to use this one right here. So I'm going to say 3x minus 2y equals 2. I'm going to substitute this in place of that y, so put a negative 4. So I get 3x, a double negative makes a positive 8 is equal to 2. A two-step equation, I subtract 8, I get 3x is equal to negative 6. I divide by 3 and I get x equals a negative 2, and I'm done. And there it is. Yeah, it was a lot of work. Yes, yes, yes. All right, last one here. If you look at this one, and copy it down right now, please. If you look at this one, you got to line up your x's and your y's. So right now, what you want to do is take this x, bring it over here, take this y, bring it over here, and then take the 14 and bring it over there. So the signs change. So the x becomes 7x plus 20y is equal to a positive 14. Over here, I'm going to take the 4 and bring it over there and bring the 2x over there. So I get a negative 2x plus 10y, because I didn't move the 10, equals a negative 4. The 4 changes because you moved it. Now you got to make something cancel. Well, you could do that one by multiplying by 2. That would give you 20. That would be your best choice. You could do those, but then you got to do both of them. So I would multiply this by a negative 2, and that's going to give you a negative 20, which is going to cancel there. All right, so your work for today is right here. And the answers are there, but I want to see some work. And what I'm going to give you today is the evens. So work the evens, okay? So 1 or 2 to 24 evens today, okay? All right, let's move on. Let's talk about geometry. What's your favorite subject? Geometry. Look up here. All right, so bell work. This was mental math. I hope you did it mentally. Does this one look like that one? Well, yes, it does. So you add them up and keep the sign. There it is. This right here is two signs together. A negative times a negative makes a positive. Now this is not the same as that, but you have more pluses. You got 2 more pluses. This one is negative times a negative is a positive, 24. This one is a two-step equation. So draw a line, circle your x. You want to add 5 to both sides. So you get 2x is equal to 15, divide by 2, and you get x equals 7.5. And there you go. All right, today we're going to go ahead and make corrections and process. If you need the 2 sheets for day 2, which is today, they're up there in that folder. Remember, you got to do your work on white paper to get credit. So let's take a look here. Let's start off. Process, reflect over the y-axis. Let's talk about that a minute. Number 3. This is my y-axis. So if the point is here and I want to reflect it from here to here, then you're going sideways. And if you're going sideways, you change the x. So if you go over the y, you change the x. So here, the x, here's the point, you can't change 0. So it's still going to be 0, 0. But you can change this one. So you're going to get negative 4 and 6, and that should be your answer, and that's what she has, okay? And this, by the way, is work from Miss Smalley, and Miss Smalley, we do appreciate it. Let's take a look here. It says, identify the transformation. Remember, a transformation is a flip, which is a reflection, it's a slide, okay, or it's a rotation. Well, look here. If you slide this point over, and it looks like it's going to go over 2 and then up 1. So the translation, you got to know this, the x is going to be translated to the right 2, and the y is going to be translated up 1. So that would be a +1. That's the rule, so you got to know that. But anyway, this one is a translation. So you slide it over 2 and then up 1, and bam, it's the same figure. All right, this one right here is a flip, it looks like. Okay, let's see what she has here. She has reflection, okay? It flips. This one right here is a flip over a 45. Remember, this line is y equals x, okay? And there's a rule for that one. I think it's flip and change, but let me see what the rule is. And you can find the rule on this 45 right here, y equals x. You can find it just by using a point. Okay, so like this point here, watch what I do, is over -2 and then up 1, 2, 3. But the new point, h prime, is over 1, 2, 3. So the new point is over 3 and then down 2. So basically all you do is switch them. So the rule for reflecting over this line from here to here is the same distance from here to here. You see? You're just reflecting it over that line, is switch. So write that down. The rule for y equals x is switch. Remember it, but you can figure it out as well. This one right here, she has as a rotation. Okay, now you might say, well, can't you flip it? If you flip it, the short side here is not going to meet that side, you see? And then this one's going to be way down there. So it's a rotation. All right, you only had a few choices there. Let's go to number 5. Look up here now, pay attention. Process. All right, so it's saying this triangle has those vertices that's rotated 180 degrees about the origin. Now this is where you got to memorize your rules. Now watch. Okay, you know I'm not big into rules, but I want you to know the rules. Let's take this point. -2, up 4. 1, 2, 3, 4. Put a dot right there. Okay, let's say you forget your rules. Well, 180, here's the origin, so put a dot by the origin. Let's draw a 180. So take your paper and draw a 180. So this line, 180 clockwise or the other way, should be over this way. And actually, my circle, it probably should be way over here. In other words, the distance from here to here should be the same as the distance from here to here. So we'll cut this one out. All right, so look at what's going on. This point is -2 and then up 4. This one looks like what? +2 and then down 4. So you got to change them. So +2 but down 4. Okay, so the rule is change. So 180 rotation is going to be change the x and change the y. See, I figured that out without even knowing the rule. So you're going to change these. All right, yeah, it took me a little while. So this one's going to be 2 and -4. This one's going to be -2 and -2. This one's going to be 0 because you can't change 0. A 0 is never a hero. This one changes to a +2, and those should be the answers she has. Let's see what she has. She has 2, -4, -2, -2, and 0 and 2, and bammo, there's the answer. All right, let's move on. Write the translation rule. Well, look here. You're going 3 and 2. This is the pre-image. And the new image, P prime, is 2 and 6. Let's take a look at this one. I like to graph it. So go over 3, 1, 2, 3, up 2. And it will help you if you graph it. Over 2, up 6. 1, 2, 3, 4, 5, 6. Okay, so it's up there. So you're starting here, so it looks like you're going to the left 1. So x is going to be a -1, and y is going to be up 1, 2, 3, 4. So that's up 4. That seems pretty easy, doesn't it? Let's see what she has. She has a -1, and then she has a +4. Now she wrote it a little differently. Probably hers is right, but there's the answer. All right, let's go on. Let's go to the next one here. Which transformation maps the solid onto the dashed figure? So you're going from here. It looks like 1, 2, 3, 4. So it's a quadrilateral, and you go on to this one here. Let's see what she said. Here's the origin. So she said if you rotate this point about the origin, so from here to here, 180 degrees, you got your answer. And there it is. And it looks good. Okay. All right, let's go on. A triangle has those vertices. Which transformation produces an image with those? Well, let's see what's going on here. Okay. So let's take point A. And we're just going to isolate one point. And then point A prime. Let's see what's going on here. So this point, the original point is -3. You got to go left, over, and then down 1. So that's point A. The new point is over 1, 2, 3, down 1. Okay, so here is A prime. So the question is, how do you get from this point to this point? It looks like they reflected it over the y-axis. See, that's your y-axis. So if you reflect it over the y, you change the other one, which is x. So here, they changed the x. You see, the y stayed the same, but they changed the x from a negative to a positive. I'm going to say reflect over the y-axis, and that's what she has. All right, let's keep moving. Let's try to get this done. Tomorrow will be day 3, where you're going to work by yourself, and the next day I'm going to do them for you. Let's take a look up here. All right, triangle, blah, 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 and our graphs below. Which transformation is going to map ABC, which is this one, onto, let me read this, ABC onto triangle DEF? Well, there's DEF, okay? Now, she went ahead and relabeled it as A prime, B prime, and C prime. So you're going from this one to this one. Let's see what she did here. It says a reflection over the x-axis followed by a reflection over the y. So in other words, if you take this point and you go up 3 and then you go up 3 from here, you're going to be here. And then if you reflect it over the y-axis, it should be somewhere over here. Maybe I'm not looking at it right. Oh, the drawing is messed up. Okay, so what she's saying is first you got to reflect it over the x, then you got to reflect it over the y. So you got to go through each one of these choices until you figure it out. Let's keep moving. What you need to know about a die, and I had to look this up, some of you might know. So right now, draw 2 squares together and then connect them. Do that right now. So we have a cube. This is actually called a die, one of them. 2 of them is a dice, plural. Opposite sides are equal. So if this side is 2, this side would be 5. If this top one is 1, this bottom one would be 6 of them. Okay? Because it's got to add up to 7. See right here? And even though they told me that, it didn't register. So like this one's a 3. So on this other side over here that you can't see has to be a 4. So you got to figure out what they did here. How did they move this? All right, so let's think. If this is a 2, on this other side is a 5. Okay, so the question is, let's see what the question is. Which transformation repositions P to Q? So you're going from P to Q. And it's real important you understand that. So let me think about this. Okay, so it looks like they moved the 3 into this position, so they're turning it clockwise 1 click. You see, because that 5, which is in the back, is now going to be in the front. Okay, you got to visualize that. So we're looking for a clockwise on the top one. So look here, rotate the top cube 90 degrees clockwise. We want something like that. We don't want counterclockwise. So we don't even have to do the bottom one because there's our choice. You see, the top one, you're moving at 1 click, 90 degrees. 4 clicks would be a whole circle. All right, you might have to go back and think about that one. Let's keep moving. A triangle has those vertices. What are the coordinates of each vertex if the triangle is translated 4 units right? So X is going to go 4 units to the right, and Y is going to go 6 units down. So that's going to be a negative. So what you do is you take your points here. So you got -7 and 6, and you're going to add 4 to that one. And then you're going to subtract 6 to that one. So the new point is going to be -3 and 0. So we're looking for that. So let's see which one has -3 and 0. There's only one. All I had to do was one of these, got my answer. Okay, don't give up on those transformations. They're easy. All right, she said skip this next one because there's no diagram. All right, let's keep moving. What is the what transformation will place the trapezoid onto itself? Well, what you want to do is, I'm thinking rotate it. If you take this thing and rotate it or flip it, reflect it, okay? Let's see, reflect it over the, see if you reflect this point over the y-axis, it will match up. You can't reflect it over the x because this point would be somewhere right there. Let's see what she said. Reflect over the y-axis. Rotation 180 degrees about the origin. Rotation about the origin. Well, remember rotation, here's the origin. So if you rotate this point, you see the distance from here to here has to equal the distance from here to here. Now, no, mine's not perfect, but it's certainly not going to be that one. So it's going to be a reflection over the y-axis. Okay, let's keep moving. Which figure has a 90-degree rotational symmetry? 90-degree rotational symmetry. Well, the square, which is the answer, if you take it and you put it in the middle of the coordinates and you rotate it 180, that should work. A hexagon has 6 sides, so 1, 2, 3, 4, 5, 6. And if you rotate that one, let me think about that one. A regular hexagon has 6 sides, rotational symmetry. All right, so what I did was a reflection. Rotational symmetry is where you rotate it. So if I rotate this one 90 degrees, let's think about that. So 90 degrees on this one would rotate it up here, and so that wouldn't work, okay? It wouldn't work. See, 90 is only 1 click. If I go 2 clicks, I think it might work, but it said 90 degrees. A regular pentagon. A pentagon is 1, 2, 3, 4, and 5, and that's not looking too good. So let me try again. So 1, 2, 3, 4, 5. That one's better. It's kind of like the Chrysler symbol, okay? So rotational symmetry, let's draw it like this. And if you go 90 degrees, this point would be somewhere over here, 90 degrees, about the origin. And actually, let me think, yeah, it would probably be right there. So that one doesn't work. An equilateral triangle means all the sides are equal. So if you rotate this one 90 degrees, this point would be somewhere up here. So the only one that rotates is the square. But you got to go through all 3 of them. And 90 degrees is just 1 click. And I think we're done. So day 2 is in the books. Make sure you rework these and think about them, okay? Remember, you can be the best. You just got to practice, okay? So day 3 tomorrow.